I'm Anirudh from Group 2 and I'll talk about how we set up Redshift cluster for our application. So this is a basic app that we built. So as you can see, we have two options right now to select between the database that we want to query, and here is the text box that we put our query in, and then when we submit we get a response as a tabular data in this section. So this is our quick process flow diagram. So as you can see, there is a text box in which we put our query, and then when we pass it to backend, we add some parameter that which database do we want to connect to based on the radio option, and this backend service goes to appropriate database and fetch the data, and then give us response or error if there is any, and then it is rendered in that UI as tabular data. So before creating a cluster, we put our data in S3 bucket. So we have created this bucket, and where we have uploaded some CSV files in which we have our data. Some files are bigger, so I've skipped the step to upload and show in this video. So right now we have like six CSV files and we'll push this to Redshift cluster. So for that, let's create a Redshift cluster. So we go to the Amazon Redshift and we see that there is a create cluster option. So right now we are building it in testing mode, so we'll select free tier, free trial. So it gives like 2 months of free trial for Amazon Redshift from AWS. So let's name our cluster group 2, and so this gives an idea like what our instance type. So we have DC2 large, and it gives us 2 CPU power, computing power, 2 cores basically, and the storage capacity provides us 160 GB for the trial period as well. So in this section we can set up our credentials and basically the database name that we want. So this is optional, so we can create a database later on as well. I mean the name later on. So now we can also mention our custom port. Default is 5439, and we can set up a master name. Let's give it AWS user itself, and master password. Okay. So it will take some time to create a cluster and make it active. Cluster ready. As you can see, the status is available. So 2 things I have to make sure. First is this cluster should be publicly accessible. Second is the port that it is using, like 5439 that we initially added. So it should be open. So let's go and check these settings. So for publicly accessible, so this is an action drop down. So we can see that there is a modify publicly accessible setting. So you have to enable it so that it is accessible from any network. You have to save the settings. It will modify and will take few seconds. Meanwhile, we can also check the ports. So for ports, this is one properties tab that you can see, and it has assigned a security network group. So let's check if the ports are open for this cluster. So in the inbound rules, you see the ports which should be active. So I cannot see my Redshift port. So let's edit this. So we have to add a rule, and we have to select the port that we have for our cluster, and we can choose among anywhere my IP. This will restrict only to your own system, but we have to make it from anywhere. So we'll select this and save the rules. Okay, now we have both the settings ready. Let's see if our cluster is available or it's still modifying. Okay, yeah, now it's available. So let's try to connect. So in the cluster settings, you'll see one endpoint is there. So this is your host name that you'll use to connect to your database. So I'm using this dbeaver tool for adding the connection, and you can search Redshift here. Yeah, so we give our host that we copied from. The port is 5439. Use database is dev, username is AWS user, and your password. So now let's test this connection. So I believe it has identified something, and it is yeah, so we are able to test the connection. It is connected successfully. So we'll do finish and connect to it. So currently we don't have any data, so let's jump to AWS and go to the query editor. So let's do some select one. So first we have to connect to database. I'll add a temporary credentials. So G2 is our cluster name, database name is dev, and user is AWS user. We can also query in here. So AWS provides the editor here itself. So let's do select one. Yeah, so basically we are connected to database and we can query our database. So what we have to do now is copy the data from S3 that we stored to Redshift cluster. With the data from S3 to AWS Redshift. So we have to make sure that this Redshift has the permissions to access S3. So for that we have to go to roles. So we'll add a new role and assign it to this cluster. So now create a new role and search for Redshift. And then add some permissions. For example, we have to customize it, so we have to select the customizable option because we have to add our S3 roles. So we don't need all access. We can just select the read-only access, and we'll be able to read the data from S3. Let's give it RD S3 role. Okay, so now we can see that we have RDS3 role here, and you can see it has some attached policies, which is S3 outposts read-only access. Now we will require this ARN number, ARN role ARN, which we will use in our command to copy data from S3 to AWS Redshift. So this is our copy command, where we have to specify the location of the file, also the role. So we have created a role, so let's just copy it here. We have to also assign the role to this cluster so that this cluster can read from S3. So we have to modify or manage the AIM roles for this cluster, and let's remove and add our role that we assign we just created. So this is the role that is created. So now we have to associate it, so just click on this and then save the changes. So it will take a while before we can use it. So let's wait for it to modify the roles. Cluster is modified with the roles. This is the command that we have to run. Let's open the query editor and copy this. So you'll notice that we still have this attribute to add. So this is basically the file name of the file, basically, which is in S3 that we want to import. So let's go to S3. So I'm creating the departments table from departments file right now. So let's copy the URL for this. Yeah, so copy the URL and paste it here. Yeah, so now our command is ready. So before importing data to table, we have to make sure that table exists. So we have to create this table first. Okay, so query is executed. If we do select star from departments, yeah, it's success. It doesn't have any data, so it doesn't return anything. So let's copy the data to the table. So I believe the region is not actually the cluster region. It's actually the region of file and that is basically the file, the S3 bucket region that we see here. So now, as you can see, the command is successfully run. So we should have some data in our departments table. Okay, so it has returned some data. Okay, so we can also check in our tool that we have. So our cluster is G2, so we are connected to this cluster. We can explore the tables that we have. So right now I have just created the departments table. So in the schema, you will see we only have departments table here. Yeah, and we can check the different properties of our data and also the actual data that we have loaded from CSV files. Okay. Yeah, so this is one table that I've imported from S3. Similarly, we can have multiple tables imported. Okay, so this is it for the Redshift part, and I believe Rasika would have mentioned about RDS for MySQL, and now Rahul and Jacob will explain about EC2 and the app that we have built. Okay, thank you.
Hello. So I am Rasika Hassanes from Group 2, and I'm going to show how to connect AWS RDS MySQL database to an application that queries the data in the database. So first to create the database, MySQL database. Um, we do free tier. Change the database name. And something recognizable. It should be. This master password is required for connecting to the database afterwards. Okay. So this is okay. We need to make the database public, or else it will not be accessed from the computer. The security groups should be default. Yeah, that's it. So the create database requires some amount of time. So the database is created. It is available, which means that it is running. So Mysql Workbench is a tool which we use to connect the database. So the host name is the endpoint. The port is 3306. Username admin. The password which we have given. So connecting to the database requires some time. Okay. So the database is connected. Our AWS database is connected. Now we have an S3 bucket in which we have uploaded all the Instacart data, which are CSV files. So okay, these are all the CSV files of Instacart. Now we need to transfer these files to our RDS database because it is empty right now. So each CSV file will become one table in our RDS database. So this is a script that we need to run to transfer all the S3 data into the RDS database. This script has all the credentials of the Instacart S3 bucket. We need to give the credentials for the RDS database. So the host databases. Okay, so this is the host name. Port number is 3306. Database name. Okay. The user is admin. Password would be what we have given. Okay. So using these credentials of the bucket and the Instacart CSV files, as well as the database credentials, we create the engine using these credentials, and then we connect in all these credentials, and then we connect the engine. And here we copy all the data from S3 to the database. Try catch is for catching any errors, right? So we need to create a database for running the script. This okay. So this database is needed for running the script because we need to create the database, otherwise the S3 stuff is not uh, is not copied to this database. So the database name should be the same as our AWS database name, and then we run this script. But for that we need the database. Okay. So now this script will be loading all the S3 files into the database. So the department's CSV file becomes the department table, IL CSV file becomes IL table, and this will take some time because the orders CSV file is very large, so it will take some time to transfer all of the S3 data to. Yeah. Okay. So all of the S3 data is transferred to our AWS MySQL database. Okay. Now this process flow diagram shows how we query the data from MySQL, and then we put it to backend, and the backend is connected to MySQL database, which gives a response, and this response is converted to table, which is shown in the app UI. So we select star from files, for example. So MySQL database, of course, we are connecting to. Okay, so it gives the whole IL table. So this is the database query that we had asked for, and this gives the time elapsed, which is needed for the for this database to be queried.
So I'll be going through the steps on how we can create an EC2 instance and load our web app onto it from S3. So the first thing to do is in the EC2 console is to go to launch instance and select the operating system template that we want. So we're going to be choosing Ubuntu Server 20.04 for it. Now we're going to choose the instance type that we want. So we're going to choose T2 micro for it this time. Now over here, we need to choose our the security privileges of our EC2 instance. So we have something called IAM role. We're going to be choosing EC2 role for it. And next, we're going to be adding the storage. So by default, it comes with 8 GB, and we are just going to go ahead with for it. And in the security group, which deals with the firewall configurations for the EC2 instance, they already have an existing security group defined called launch wizard 1. This already has ports for port number 80 and port number 443 open, so we can connect to it you can connect it through using HTTP and HTTPS. And if you look at the source IP, it's open for any IP address from the outside a network, from any network outside AWS. So we have 80443. We also have port number 22 open for SSH. Now we can just click launch instance to launch the EC2 server. Now before launching, it'll ask for a key pair that we have already key pair. We can either create a new one or we can create an existing one, and we are going to go ahead with the existing key pair. And now our instance is created and it should be visible in the EC2 console. So over here we can see our newly created instance. If you look at the instance state, it shows pending. That means it's still booting up. So once it's booted up, it'll change from pending to running. So now we can see that our instance is running and it has been assigned a public IP address over here. And we can use this to SSH into our EC2 instance. So in a bash terminal, to SSH into the instance, we just type SSH-I, and we give the name of the data, we give the name of the key pair file that we have already created before, along with the username at the IP address that we want, the IP address of our EC2 instance. Just click enter. And now we have connected inside the EC2 instance. So now that we have access to our SSH instance, we can now go ahead with installing the necessary packages for Python as well as the modules for our web app that you're going to be using. Now the packages ngix and unicorn are going to be the web servers that are going to actually host our web app and serve it whenever there is a request to either port number 80 or port number 423. Now finally we can go ahead and install AWS CLI. So this will help us install, help us copy our project files from S3 onto the local EC2 machine. So now that we have installed AWS CLI, we can just use it to copy all the files from S3. So we just go ahead and create a folder to hold all the files from S3. So we just name Flask app, and then use the AWS comma CLI to actually copy it from S3. So AWS S3. So now we have copied all the files from S3 onto the local folder Flask app. So you can just go and check it inside the folder. So there we have all our Python files and all the requirements. Now our web app requires a bit more extra modules that we need to download it from pip. So we can just, so all these are mentioned inside the file called requirements.txt. So these are the three extra packages that we need: Flask, py-mysql, and py-es5 copg2. So we can just directly install it in one command using pip. Before we can actually start running our web app, we need to first configure Nginx. So for that, we just create a file in its configuration folder along with all the prerequisite configurations such as IP and port number that we're going to be assigning to our web app. Now, since that's done, Nginx will actually be serving our static files such as any JavaScript or CSS files. Codicon will be actually hosting our Python web app and responsible for doing the doing the query to the SQL server and such. So now we have our Python web app running. Now that we have our Python web app running inside EC2, we can just use the public IP for address to access our web app. So now, as you can see, we have access to our Python web app over here.
Hi everyone. So in this section we are going to take a look at how the web app is designed, how we developed the code, what all of the packages that we used, and how the workflow is like. Okay. So in the case of this project, right, we have used a Flask application in order to deploy the web app. So the final output of this web app looks like this. So this is the website that we have built. And you have a form here where you can execute your queries and the results will come below. Okay, so we'll try to link the UI with the project so that it makes more sense. Okay, so this is the basic structure of a Flask web application. So you have these particular files and folders. So I'll give a brief overview of the folders and then we'll get into the code. So the first folder, static.py. Static is holding all the static files that is used in the website. So like the CSS which is used for styling, or the fonts that's being used, or the background, the parallax image that you see here, Rutgers University picture. So the background picture, everything is actually kept inside the static folder. Then the templates hold the rendered file, which means that it holds the HTML files which will be rendered by the Flask application in order to display this output, right? Okay, and then you have this requirements.txt which tells you which all are the packages that we have used here. So we have used Flask, this version, PyMySQL, which is used to establish the connection to MySQL, and it's this version. And here we are also using a PostgreSQL wrapper in order to connect to Redshift. This is the package name, PsyCops2, and this is the version that we are using. And then you have two more files, application.py and db.py. So application.py can be considered as the entry point to the web app. So it first this is the file that runs, and this defines which template to render and which connections to call, and how to get the data, how to transfer the data between the layers. And db.py holds the functionality to connect to a particular db and fetch the records, and it returns the records. It also calculates the amount of time required to execute a particular query. Okay, so yeah, let's start with application.py. So in application.py, so when we look at this website, right, you will see that the website link is like this, right? So it ends with a slash basically, and slash means home page, right? And that's why we have this app.root / render template index.html. So when we run this particular Python file, it will initialize the Flask application, and then it will look at this particular endpoint. So the endpoint here is .NET /. Whether you give .NET or .NET /, it's essentially the same thing. So it looks for that endpoint, and then it renders this template, and the template it renders is index.html. And let's look at index.html. Okay, so in index.html, we are defining some sections. So the first section is called the hero section. The hero section is nothing but this particular section that you see here. Okay, so as you can see, CS527 project, team data stars, it's defined here, and then you have a button which takes you to the actual form submission part of it, right? So that part is called querying. So this is the button part, and that button takes you to querying, and this section called querying is what you see here. Inside the querying section you have a form defined. So this is the form that we have defined, as well as this title, database, instacart, and the process flow diagram, which is a link. So the process flow diagram is a representation of how the application works. So basically what happens is we have these DBs, and this particular DB, once it executes a query and then it returns the results as a particular format, and then this particular response is displayed as proper output as a table in the final UI. So this is a simple process flow diagram. Okay, and once that's done, you have this form. In this form you have these things. So the first part is a radio button. So in the source type we are accepting two type of sources. It's either MySQL or Redshift. So it can be either one of them but not both of them. That's why it's a radio button. Then in the enter your query part, it's a text area. So enter your query and it's a text area. Okay, so here you can give whatever query you want. For example, select star from departments. Okay, it can be anything. It's fine, right? And once there is also a submit and reset button. So if you click the reset button, it gets reset, and if you click the submit button, then what happens is it does an action. Okay, so here after you enter your query, you have two buttons, reset and submit button. The submit button does a reset, and the reset button does a reset, and the submit button is linked to this action. So when somebody clicks the submit button, it calls a /querying action. And so /querying, if you remember from what I said before, /querying is another endpoint that you will see. So when we call /querying, it comes back to application.py, and it looks for the endpoint /querying. /querying does some functionalities and then renders another template. So let's see what happens. So let's say I'm giving select star from departments with MySQL DB, and I click on submit. So I have the data loaded here. It talks about it says how much time it took for the query to execute, and the department ID and department. So basically the data that was returned. So how that works is defined in query. So first we get these two parameters, source and query. This is the source parameter and this is the query parameter. Once we get that, we are looking at what type of source we are dealing with here, MySQL or Redshift, because we had two options, right? And based on that, it calls its corresponding class, so corresponding function. So connect MySQL and connect Redshift are two functions that we had defined in this particular db.py file. And let's go over this for a minute. It follows the same pattern. So first you get the connection. So if you're not passing anything, it's gonna automatically look at localhost, these connections that I given here. But if you are passing something in, like we are here, then it will connect to that particular host username and password. Once we have the DB connection, we set a variable called start time, and this start time will be used to get the total time elapsed. Then we are going to execute the query. We will get the column information of the query. We will get all the results, all the rows that was returned by the query, and then we are calculating the query time. So that's nothing but start time and the current time. So current time minus start time, and we are appending millisecond here. Okay, and sometimes when you have a very big table, it's not such a good practice to display all of them together in the web UI. So we limit the results if that's the case, and we display message the result is too large to transmit, so we limit the size. Okay, and once that is done, we have a for loop here which gets the column names into a proper list, and we are returning three values: the column name, the result. So the result is the set of rows, and the query time, which is the total time elapsed. It's a similar pattern in Redshift. So we have the start time, we are executing the query, and we are getting the rows, all the rows, we are getting the column names, we are getting the total time elapsed. We are truncating the data if it's too big, and then finally we are getting the column names, and we are returning the column name with column names, result, and the query time. Then as you can see, this is a try catch block. For both of them we have a try catch block, and what happens is, let's say you gave an invalid query, and then it's not shouldn't throw any error or something. Instead, it should gracefully display the error that happened in the website itself, in the web app itself. So that's what we are doing here. We are displaying the message if something goes wrong for both MySQL as well as Redshift. So let's try that out. So we do not have a table called depart, so I'll run it in MySQL. So it says the query failed with error code, this error code, and the error issue is this one, the table instacart.depart doesn't exist. Similarly for Redshift, if I do the same thing, relation depart does not exist. So it throws the error in a user understandable way rather than just breaking the front end. Okay, so now that we know what db.py does, let's go back to this file. So once we have this connection established, we are calling the run query function. So the run query function is what's defined here, which does all the processing for us. And the run query function returns three things: the set of column names, the rows, and the query time. We are disabling the connection, disconnecting from the DB, and we ask the Flask application to render the template table.html with these data. Okay, so the data headings, the rows, and the time taken. Whether it's Redshift or MySQL, it's the same thing. So we are just calling it here. Okay, and as you can see here, there is a call name thing, a call name check. So let's say you ran a unsuccessful query, then there won't be any column names that will return, right? So that's the factor that we use in order to say whether in order to see whether the data will return or not. So if column name is not none, that means okay, I have a table with and the SQL query executed successfully. So enter the template with headings, with data, and with time taken. And if I do not have column name, then there will be no headings, no data, just the time taken, and the time taken will be the error message that was returned. Okay, so let's look at table.html now. So in table.html, we are using a Jinja template in order to render the table. So it's kind of like a for loop. So first we come here and we check if there are any headings. So in here the headings mean column names. If there are column names, then we are looping over it and printing all the headers. So let's start from departments. Yeah, so that's this part. This department ID and department gets populated by this section. Then the second section, which is the body section, checks if there were any data which came in, and if it was there, it loops over each row and it prints out each cell one by one by one. Okay, so that's what happens here. Right, and even before that we had this time elapsed 5 or time elapsed part, right? So that's printed out here. So as you can see, we have this time taken, which is what prints the time taken. Yeah, so now let's look at the UI a bit more. So that's the entire code. In index.html, like I said, once we click on submit, the querying gets executed and it gets appended into this result section. Okay, so when we open this, we'll see that there is nothing after this. Yeah, I'm at the very bottom and there is nothing after it. That's because this result section right now is not populated. But when I give something, select star from departments and submit it, the data gets populated here. And what happens is that we are calling a JavaScript function which gets the data from the Flask application or the application.py file, and it loads the result section based on the data which came back in. So it's dynamically generated, it's dynamically populated so that the website doesn't have to refresh on each call. Okay, so we are using JavaScript for that part. Yeah, so select start from departments. It took 12 milliseconds in 30 milliseconds in MySQL. Let's run the same thing in Redshift. So in Redshift it took only 5 milliseconds, which is way more faster. And even when we throw an error, start from depart, it gives the proper error for MySQL or Redshift, whichever one we are using. Yeah, so that has been the demo for the website and the code walkthrough. Thank you.